Push that rock here with Simpson Math. Let's talk about the composition of functions. We compose f of g means this is the notation here, but it simply means we put g into f. So here's the input space for f, and notice I have g inside of it. That's the definition of f composed of g. So we compose f of g by placing g as the input to f. Here's an example. We have f being the parent quadratic, x squared. G is just a line, mx plus b, the slope is 1, and the y-intercept is 3. F composed of g means we take this x plus 3 and we put it in place of the input for f. So this x goes away and is replaced with x plus 3. So I'm going to take this x plus 3 and put it in place of the input into f. So that means this goes away and I should have x plus 3 being squared instead of just x being squared. And that's what f composed of g is. So f composed of g, in this particular example, is the quantity x plus 3 being squared. So it's the quadratic, shift to the left 3 places. Okay, that's a very algebraic example. Let's find another example. Let's think of an encoding. This is a very childish cryptic system, but let's think of an encoding system where we simply move each letter down one in the alphabet. So maybe you're writing in your diary and you don't want your mother to see your messages, be able to decipher it. So she sees this writing and this looks like complete gibberish. But all you've done is moved each letter one down in the alphabet. So N follows M in the alphabet, F follows E, T follows S, B follows A, H follows G, and F follows E, and so message becomes, I don't know if I pronounced that correctly. Now, the decode function takes message and backs each letter up one. So if you back up M one place in the alphabet, you land at L. And right before E in the alphabet is D, and right before S is R. There is no letter before A, but maybe you treat it circular, and so you make it Z, because Z is the last letter, so you think of it as a circle. And then G, the letter before G is F, and the letter before E is D. So the decode function takes the word message and makes it I don't think I pronounced that correctly again. Sorry for my pronunciations. Well, what happens if we compose D composed of E, the decode composed of the encode? What do you think happens? Take a wild guess. I'm sure you guessed correctly. If you decode the encode, you get the original message. So here we have the encoding math put into decode. Well, when you encode math, you just push everything down a letter. So M becomes N, A becomes B, T becomes U, and H becomes I. But when I decode, I back up a letter. So N backs back up to M, and B backs back up to A, and U backs back up to T, and I backs back up to H, and so I'm back with math. I'm sure you really enjoyed this lesson. This is Simpson Math, where we make math simple.